So here is a function for insertion sort which is taking an array and number of elements. In our example, the size of an array is 5, so n is 5 here. So let us assume that this is 5, but the indices are from 0 to 4 only. Now first is for loop for passes. How many passes for n elements? N minus 1 passes. But if you see the passes, in first pass, which element we are trying to insert? That is second element at index 1. So we are trying to insert this one, right? So this is index 1. So we don't have to start from 0, we have to start from 1. So insert the element from index 1, then 2, then 3, then 4. So this loop should start from 1 onward. So I takes values from 1 and I is less than, till 4 it should go. So less than 5, less than n. So till 4 it will go, then I plus plus. So from 1 to 4, because at 0th index we have the first element and that we are assuming it's already inserted. So we are starting from this one. So this is for repeating passes. Then in each pass what we are supposed to do. Then I will take one example here. From that we will learn what we should do in every pass. Then we will write on the code. Now I have an example, an array of size 7. In this already till here the elements are sorted, that is 0 to 5. Now I am inserting 10. So take out 10 in some variable, let us say x. So right now I am inserting this element. So this I is present here. I is pointing here. So this is the element that I am inserting. So that element I have taken in x. Now I have to shift the elements and make this 10 insert in a sorted position. So right now this I is on 6. Now what is the procedure? So I should start shifting from where? This element onward. So I will take j here. J is I minus 1. Yes, the first thing I need is j. J is I minus 1. Yes, I need this j. And also I should take this last element wherever I is pointing, that in x. So yes, I will do this also. X assign a of I. That is the element that was present here, right? So I am taking in x. So I am assuming that it's not there. Then what is the procedure? I have to shift all greater elements. So I should compare a of j with the element x. This is greater, so shift it and j minus minus. This is greater than this, shift it, j minus minus. This is greater than this one, 10, so shift it, j minus minus. This is greater than this one, so shift it, j minus minus. Now this is small, stop. So the procedure is very simple. Go on shifting the elements as long as a of j is greater than x. So yes, while a of j is greater than x, go on shifting the element. So wherever j is pointing, move the element to the next location. A of j plus 1 should be copied with a of j, as well as j should be decremented. This is what I have to do for shifting the elements. And right now this 20 is moved, 18 is also moved, and 14 is also moved, 12 is also moved. This place is free, right? This place is free. So this element we got it smaller. So this element 10 should be inserted at which place? J plus 1. So once you come out of this loop, the element should be inserted at j plus 1. J plus 1 assign x. That's all. I have stopped this loop also. Now one more thing. This place I left it empty. So let us observe. Suppose this is not a 10. If this is 2, then what happens? From this point if I continue, 8 is greater than 2, shift it, j minus minus. 6 is greater than 2, shift it, j minus minus. So j became what? Minus 1 now. So stop. So when j becomes minus 1, stop. Means continue as long as j is greater than minus 1. So one more condition I should write down, j greater than minus 1 and this condition. So this is the algorithm for insertion sort. We found that the time complexity of insertion sort is n square. And here from the code, if you see for loop, then inside that while loop. So two nested loops are there. So this is n square. So from the code also we can say it is n square. So next thing that is remaining is we have to check whether it is adaptive or stable or not.